Some of you wrote some of this down last class. Today is October the 24th. So this is what we ended with last class, looking at perfect squares with fractions and decimals. So if you take a fraction and multiply it by itself, then we would say 4/9 is a perfect square. If you had a decimal like 0.64, which is equal to 64 over 100, which is 8 times 8 over 10 times 10, then 0.64 is considered a perfect square. So here's our first question. We are trying to figure out whether these numbers are perfect squares or not. The first thing we're going to do with our fractions is if we have a fraction, we want to write it in lowest terms. Is 8 over 18 in lowest terms? What can you divide each of them by? You can divide each of them by 2. It would become 4 over 9. Divide that one by 2. Divide that one by 2. It is a perfect square. Why? Because the top number is 2 times 2 and the bottom number is 3 times 3. So we needed to know our rules for multiplying fractions, right? You multiply the tops, you multiply the bottoms. If we know our rule for multiplying fractions, that helps us see if it is a perfect square or not. So A, the answer is yes. It is a perfect square because you can multiply a number by itself to get that. For B, 16 over 5. First question we ask, is it in lowest terms? What? Can you divide? You can't divide 16 by 5, so this one is already in lowest terms. Is there a number that times by itself is 16? Is there a number that times by itself? 2 times 2 is 16?
2 times 8 is 16.
Right, but those aren't the same number. 4 times 4.
That's 12. No, that was 16. 4 times 3 is 12.
Okay. And then 5, if we try to do 5, is there a number multiplied by itself that's 5? No, because we know 2 times 2 is 4, 3 times 3 is 9. There is no nice number that goes here. So our answer to this one is going to be no. No, no.
That's what my mom says. I say, Mom, she's like, no.
Okay, if you go to your calculator, so if on a test, you're asked to check, are these numbers perfect squares? Our first one was 8 over 18. You can go to your calculator and do square root of 8 divided by 18, just like it has, push enter, and if you get a decimal, can you see this decimal is repeating? If your answer is a rational number, and a rational number is any number that can be written as a fraction, or as a decimal that stops, or a decimal that repeats. So our definition of what a rational number is can tell us, because this is a rational number, this is a perfect square. My calculator has a fancy thing on it where I can change a decimal to a fraction if I want. And we find out that the answer was 2/3. The second one, probably. The second one that we have, yeah, you have yours would. The second one that we had was the square root of 16 divided by 5. This time, when I put it into my calculator, I get a decimal again, but this decimal doesn't repeat. The numbers are sort of looking random. There's no pattern that keeps on going forever. This makes it an irrational number. Anytime that you get an irrational number, the answer of whether or not it's a perfect square will be no. Part C, 2 over 9. Sometimes I think these questions are actually easier without a calculator. If you were multiplying fractions, you could get 9. What would I have on the bottom of my fraction, Logan, if I wanted to get 9? Yeah, good job, Logan. 3 times 3, right? If we're trying to multiply to get to 2, okay? If we're trying to multiply to get to 2, there's nothing that works here that's the same number. You could do 1 times 2, but that's not the same number. And if you can't put the same number there, we're going to say that no, this is not a perfect square. For the decimal ones, 6.25 and 0.627. Again, we're going to go to our calculator and check these ones out. Square root of 6.25. It works out perfectly to a number that ends 2.5. Since that decimal is a rational number, a decimal that terminates is a rational number. It can be written as a fraction. The answer is yes, it is a perfect square. If our decimal that we plug in, 0.627, which is the next one, is a decimal that keeps on going with no pattern, then we say no. So here's our next ones. You can use your calculator. You can borrow a calculator if you do not have one. Okay? Again, I'll hand some out here. One more for Cherish, doesn't have one. Anybody else need a calculator still? Sure, there you go. Still haven't found yours? Okay. What number goes where the question mark is? How could we use our calculator to help us figure this out? Okay, could get an estimate, but let's look at one that we know. If you know the square root of 9 is 3, why is it 3? Because 3 times 3 equals 9. So now in our question, we have the square root of something equals 12. This number is this number, right? So what could I type into my calculator if I write, what could I write here? Look at, I know the square root of 9 is 3 because 3 times 3 is 9. Square root of something is 12 because 12 times 12, this is where our calculator comes in handy. What is 12 times 12? 144. Since 12 times 12 is 144, what number's inside that square root? 144. Does that make sense? So we don't actually need to estimate here. We can figure this out completely. What's going to be inside of this one? 3/4 times 3/4. How do we multiply fractions? What's the rule for multiplying fractions? Bottoms with the bottoms, tops with the tops. 3 times 3 is? 9. Bella, 4 times 4? Yes. Good job. Okay? And so we know the second one, the question mark, is 9/16. The third one is a decimal. Okay? So for sure we're going to need our calculator on this one. I'm going to try to do it in my head. You can check if I got it right. 1.8 times 1.8. Is it 3.24? Good. So our question mark in that one would be the square root of 3.24. If you get questions like this, the other nice thing, the part about math that I really like, is you can check, is 3.24 the right answer? Right? How do I check it? I go to my calculator, I say, well, what is the square root of 3.24? If it equals 1.8, I know that I got it right. If it doesn't equal 1.8, I know I made a mistake. I push enter, 1.8, perfect. Okay? If you take the time to think about the math and what we're doing, math is really kind to you because on a test, when you get an answer, you can check to see if it's right. And that's a good thing, right? You don't get that on a science test, right? They ask you what's the definition of mitosis, and you can't type in mitosis into your calculator to check if it's right. I guess you could type it into your phone, but that would probably be considered illegal on your test.
What would be illegal? Things are illegal on a test?
Do you think your science teacher would allow you to say, the question is, what is the definition of mitosis? And you go, oh, I'm going to type it into my phone and write down what my phone says?
It depends on what teacher.
Depends on what teacher?
I don't think that's illegal.
That's honestly true.
My teacher let me know.
There you go.
Maybe because you're in this class now. No, I was in the right one. Do you know what this class is called on the map?
One of the reasons we call square roots is because they deal with squares. If you had the square root of 9, could you make a square that has 9 blocks in it?
Yes.
Right? And how much are each of the sides? 3 and 3. Square root of 9 is equal to 3. And all of those squares are 1 unit for area. The square root fits with that because the area of a rectangle or the area of a square is length times width. So if you can make a perfect square, and that's another reason those numbers are called perfect squares, is because you can use 9 blocks to make a perfect square. If you can make a square, then the side length will be the square root of that number. Okay, so
When we post them and make your everything right up top.
the outside square here is 5 by 5. The inside square here is 4 by 4. And with the bright yellow line, I made a square in between. I want you to use your counting skills and tell me what the area of that yellow square is. So in the 4 by 4 one, the blue one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 squares in the blue one. How many squares are in the red one? The 5 by 5? 25. Now, if I do that yellow one in between,
You put them all in the wrong spot.
hmm?
You put them on the wrong spot.
What did I put on the wrong spot?
The markers.
Yes, I'll fix that for you.
It's making me uncomfortable.
There you go. It is confusing, right? Because if I put the colors on the wrong spot, then the black pen is actually
Green.
green.
Draw Bella.
I just did. Come on, can't you tell? So happy. Okay. With the yellow one, the yellow square is going to be somewhere between 16 and 25. If we wanted to count it out, would you agree that this is a half of a square and this is a half a square? Those together would make a full square. So I want you to count out the area of the yellow one, knowing that those are halves. Riley, so do you know what the question is that we're working on?
How many is inside the blue square?
Close. We're trying to figure out add up how much is in the yellow square. You already know that the blue square makes 16. The yellow square has a bunch of halves in it.
6.5.
Okay. Close. These two, what do two halves together make? 1. So that would make another one, making it 17.
Oh, I thought
And then these two halves would make another one, 18. And then these two halves, 19. These two halves, 20. How much is this little part there?
5.
Is it half? Or is it less than half? I'm going to zoom in. I'm going to zoom into this circle, to that last square. Here's the last square. Here's the yellow box in that square. It's cut halfway here and cut halfway there, and we only got this amount. What fraction of the whole thing is that? 1/4. This is 1/4. If I wrote with yellow all the time, I think it would hurt your eyes. So I'm going to switch back to regular color. So we just counted, there's 16, 17, 18, 19, 20, plus 1/4. The yellow square has an area of 20.25. 20 and 1/4. This is in our rational numbers, because rational numbers means if you can deal with whole numbers, we also want to be able to deal with decimals. What is the size of the yellow square? When I cut this line perfectly in half, can you see that your yellow square, again, sorry for using yellow, is going to be what's right in between 4 and 5? 4.5 and 4.5. So with this diagram, check out some things on our calculator. If I do the square root of 20.25, we get 4.5. If I do 4.5 times 4.5, which is the area of that square, I get 20.25. It's kind of neat, because that kind of math, I would say 4.5 times 4.5, that's not easy to do in your head. Square root of 20.25, not easy to do in your head. But sometimes if we think about the pictures, if we think about what's actually happening, we can do more complicated math because we look at a diagram and we figure out what it is. You could use this strategy and you could draw out a 5 by 5 square and a 6 by 6 square, and you could figure out what 5.5 times 5.5 is.
will we get to play?
I don't think so. We're taking too long. another way we can think of decimals. Okay? If we take a square, a regular square that's 1 by 1. So this is regular numbers 1 by 1. But then you break it up into 10 pieces this way and 10 pieces that way. I don't know if I counted right. There might be more or less. And if we break it up into a grid like this, and so on, we're going to get 10 little squares this way, 10 little squares this way, 100 squares. If you break up a 1 by 1 into 100 pieces, this is our fraction, then one of these pieces represents 1/100th of the whole square. If I shade 36 of those squares, that number represents 0.36 because it's 36 100ths. And if I have 36 little squares, does it make sense that there are 6 squares along here and 6 squares along there to make 36? And since I've divided that length into tenths, that really means that I have 0.6 times 0.6 is equal to 0.36. Okay. Oh, this is exciting stuff. 0.6 times 0.6 is 0.36. 0.36 is a perfect square. You could have also done this with your fractions. 36 is what times what? 6 times 6. 100 is what times what? 10 times 10. 6 out of 10 as a decimal is 0.6. One of the things that I really like about math is the stuff that we did earlier, like changing fractions to decimals. It comes back and we get to see it again. We're like, oh, I'm glad that I learned it there because it's helping me here. And then we get to multiplying with decimals. Have you guys ever multiplied with decimals before? Okay. It's actually not bad at all. I'll teach you multiplying with decimals in 10 seconds. Okay. 0.2 times 0.6, okay, is 0.12. Do you know what 2 times 6 is? It's 12. 0.2 times 0.6 is 0.12. I'm going to get one that you're going to get wrong. What's 0.1 times 0.3? See? Perfect. It's 0.03. I chose it because I knew you'd get it wrong. What you do is you multiply the numbers like normal. So most of you got 0.3 because you did 1 times 3 and then you wrote it as a decimal. But with decimals, what you do is you multiply the numbers. 1 times 3 is 3. We had 1 decimal place here and 1 decimal place here, so we need 2 decimal places there. So if I would do decimal 002 times by decimal 09, what's 9 times 2? 18. How many decimal places do we have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's the answer, 0.00018. There's your 10 seconds multiplying with decimals. Is it that hard? No, one new rule, regular multiplying applies. So here's some questions to practice. We can estimate square roots that are fractions. Square root of 7.5. What square roots do we know that are close to 7.5? What's a square root close to 7.5?
Oh, 7 or 8. 32.
What would go in the square root? What would give the square root that's close? Okay. If I put in 4, the square root of 4 is 2. What else is close to 7.5?
5.
But 5 isn't a perfect square.
3. 4. 3. 9. Oh.
Square root of 9 is 3. So what would I estimate 7.5 to be? Maybe 2.5.
5.
Sure, try it. 2.5 is close. Go to your calculator, do the square root of 7.5, and you will find out that it is 2.738. Okay, second one. Square root of 8 over 5. Let's do square roots that we know. Sorry, I'll write one big square root. I know what's close to 8? 9. I know the square root of 9 is 3. What's close to 5? 4. Square root of 4 is 2. I would estimate this to be 3 over 2 or 1.5. Try it on our calculator. What is it on our calculator? It's 1.6. So we were pretty close by estimating 1.5. Same thing with this one. If I'm estimating, what square root is close to 3? Square root of 4. I know the square root of 4 is 2. What square root do I know that's close to 10? What square root do I know that's close to 10? I know the square root of 9. So this is approximation. 3 out of 10 is close to 4 out of 9, which is close to 2/3, which would be 0.6. What's the actual answer? 0.54. How was our estimate? Pretty good. Okay? Why is estimating important? Right? You can always use your phone to figure out something exactly if you have your calculator on your phone. Okay? But sometimes it's not cool to take out your phone, or sometimes you just want the answer quicker. That's where an estimate comes into play. You would like to know, right? You're buying a $5 item and a $7 item, and you get to the till and you give the person a loonie. They look at you like, what's wrong with you? You're buying a $5 thing and a $7 thing, and you think you can pay for it with $1. It wasn't a very good estimate, right? If you take out a $10 bill, they look at you like, that's not enough money. Didn't you do an estimate? $5 plus $7 is going to be more than $10. And so being able to do an estimate is important. You're like, it's $12. I will need to have at least $15 to pay for this and then get change back. Now, $5 and $7 you can do in your head. But if it was $4.80 and $7.15, all of a sudden the decimals get too much for our head. But we say, well, I'm going to round that to $5 and $7. It's going to be around $12. Now I know how much money I need to take out to pay for it. Or you can just use your debit card and spend all your money slowly. All right. Let's do one last question. Your friend asks you to help him with his math. He wrote that the square root of 6.4 was equal to 3.2. The answer is wrong. How could you show them that he's wrong? How do you know with an estimate that he's wrong? You could have got a calculator, right? You could go to your calculator, you type it in, what is the actual answer? 2.5. It's around 2.5 as the actual answer. So you could show him on your calculator that that's why he made a mistake. But if we wanted to say right away without our calculator, how do I know he made a mistake? Well, I know the square root of 4 is 2, and the square root of 9 is 3. Square root of 6.4 should be somewhere between 2 and 3. And he got an answer that was bigger than 3. Any idea what he actually did on his calculator? Okay, he added instead of multiplied, right? To find out the answer, 3.2 plus 3.2 makes 6.4. Instead of finding out what number times by itself makes 6.4. Here is, if you write this down, page 78, questions 5 to 15. That is due for Monday.